Assalamualaikum. Hello to our judge. Today we want to present about our final year project. This is our prototype Airborne F4D Detector. First of all, we want to introduce our supervisor is Puan Rosmawa binti Hussein, and I, Muhammad Hasib bin Khairul Anwar, 24 Dam 18 F1122.
My name Muhammad Amirul Fitri bin Ismail, 24 Dam 18F 1090.
My name is Muhammad Kamal bin Adam, 24 Dam 18 F1092.
My name is Nuran Shaira binti Noaizat, 24 Dam 18 F1089, and we would like to say thank you to Polytechnic Banting, our supervisor Puan Rosmawa binti Hussein, our judge Puan Norlia and Encik Firdaus, and also 3 software that we use, which is Arduino software, Tinkercad software, and AutoCAD software.
Okay, first of all is background of study FOD. Definition is any object found in an inappropriate location that can cause damage on equipment, an airplane or airport personnel. Damage attribute to a foreign object that can be expressed in physical or economic terms that may or may not degrade the product, required safety and or performance characteristic. Effect of FOD: flight delay and cancellation, schedule disruption caused by the need to reposition airplane and the crews, additional work for airline management and staff, potential liability because of injury, loss of life. Example of FOD: bird strike, ice, and tools on the runway. Problem statement. First is FOD normally located at an inappropriate areas such as at the airport runway and taxiway. Second, FOD that are present on the runway such as bird may adversely affect fast-moving aircraft. Third, FOD can cause damage on aircraft engine and tires. Project objective. First, to design a functional hardware that is applicable in detecting airborne FOD. Second is to develop a more effective system, software that connect to the device. Third is to demonstrate the device operation in detecting presence of foreign object.
Product function and operation. First, act as a device to scan and detect any foreign object in front of RC airplane in range up to 3 meters. Second, data can be transmitted to up to 10 devices at one time. Third, the transmitted data shows accurate location of any FOD by referring to angle and distance. Product application. Implementation of new technology in detecting foreign object. Enhance safety awareness about foreign object damage among students. And the last one, encourage people in aviation field to make a further research and develop it into a real product.
Next is product description. Arduino Uno control the microserver that will rotate the ultrasonic sensor for around 180 degrees to enable the ultrasonic sensor to scan its surrounding. Next, the data will be transmitted to web browser via Arduino Wi-Fi. Next, the web browser can be opened up to 10 devices at one time. Data received are recorded by the distance, angle, and coordinate of the object. And the last one, the device will be put inside a 3D printing case, then it will be attached on the top of the RC aeroplane.
Okay, first is this is our individual project scope. Hasif is me, hardware electrical. Assemble the electrical circuit of the device. Responsible for the electrical connection of the device. Run testing and troubleshooting of the device.
For my individual project scope, Amirul, web browser software, in charge of the radar web browser software progression and development, manage the connection between the radar, web browser, and mobile device. And the last one, responsible in extracting any information from the radar.
And me as Akmal, my scope project is casing design. Design the casing device to be shaped like airfoil that help the air flow smoothly. Determine the component and material of the casing for the device. Make a 3D printing design using a Tinkercad.
Okay, I'm Ain. I'm responsible for hardware component. My scope is determine the electrical component to be used on our hardware, design the hardware circuit, and responsible in gathering information about operation of each component used.
So this is product testing. We power our device with a power bank. In the real project, we actually powered the device using a RC Airplane battery, and the data has been transferred to the web browser as shown in the radar. So this is product demonstration. We put the object at the different distance to test whether our device is functioning or not. The first one, we can see the object is 60 cm from our device. And after I change the distance of the object from our device, the data outcome are different, where it exceeds 60 cm and almost reach to 160 cm as the result being shown. So next is product sketch, dimension and connection pin. So first, it show the device and the casing in AutoCAD. Next, the connection pin. There is component that we use: ultrasonic sensor, servo, Arduino Uno, Arduino Wi-Fi, capacitor with 200 microfarad, and two types, which is 5 volt and 3.3 volt. So next is our device: height 5.8 cm, width 4.5 cm, length and is 7 cm. And that is our RC airplane that we buy from the RC shop.
Okay, next is casing sketches or layout. The first one is before we combine the two parts of our 3D printing casing. The height will be 9 cm, length is 15 cm, and the width is 12 cm. So the video shows how we're going to
So this
insert
is how it works. We're
our
going to take the
um,
pink part,
casing.
then we put our device into it, and then we're going to slot in into the gray part like this.
Okay, so next, this is some of the problem that we encounter during our project making. The first one is solar panel cannot be used because it too big and heavy. The next one, Arduino Uno can only transmit data and display radar using cable that connected to laptop. Next, the price for developing programming code is quite high. Casing cannot be printed because of the CMCO. And the last one, demonstration using RC aeroplane couldn't be performed because our device, RC aeroplane model and the remote control are at different location. So the solution that we came out to encounter this problem is the first one, charge the device directly using battery from the RC, use Arduino Wi-Fi to transmit data and display radar wirelessly to smartphone or laptop, do some survey of various programming shop and negotiate the price, using Tinkercad software to illustrate the casing device, And the last one, using alternative way to demonstrate the performance of the device. Okay, next is commercial value. First, portable. Our product is very light, easy to carry everywhere you go, small, can fit in any RC and detachable. It means you can separate it from the RC anytime you want. Next is user-friendly. Our product is reliable, thus not prone to malfunction or crash. Simple, operation is not very complex, but instant is straightforward and easy to understand. Intuitive, require minimal explanation for how to use it or how to troubleshoot it. And efficient because our product can connect to multiple devices at one time. Next is eco-friendly. The first one is self energy. Our product use a power module that can be rechargeable. Next is low maintenance because our product is easy to troubleshoot when it have any problem. Next is costless because our product use a low cost material but high quality one. For the originality, our product is a prototype that based on already existing idea of detecting an object but in a new form factor. And the last one is price. For RC model is 180 ringgit. For battery is 50 ringgit. For casing is 100 ringgit. For receiver is 160 ringgit. And the device is 530 ringgit. Okay, that's all from us. Thank you.
When you come through the room, I know that you know if you fall, I will be there. Let's light up like the moon. Yeah, we take it off, make it even brighter. That's what I like about you. Hey, that's what I like. Tell me what you gonna do. Know that I want you, you know that I need. That's what I like about you. Hey, that's what I like. When you put me in the mood. Hey, that's what I like. That's what I like about you. That's what I like about you. That's what I like about you. That's what I like about you.
Hello and hi to all. Okay, today I want to present to demonstrate our project is our Airborne F4D detector prototype. Okay, this is our Cessna with the device, and then this is our radar. Let's show the location all of that, the system we use. So okay, right now I want to show you about the material that we use on the project. Okay, this is our Airborne F4D detector prototype. Okay, this is the device inside here, the device that we made. And then this is our casing. On the outside is our casing. We put on the top of the Cessna. Okay, like you can see, the material we use for 3D printing is PETG, volatile electrolyte glycol. Okay, for that one. And then we made it design, and then we print out to put the device inside there. And then like you can see, the device is rotating 180 degree to scan all of foreign object in front of this Cessna. Okay, here is the radar that we use. We made the website radar. On the device we have the Wi-Fi, and then when we made the website radar. Okay, here is the 60, 120, 180, 240 and 300 is the length, the range length for the object. And then is the 0 to 90, 90 to 0 is the degree of the object. The ultrasonic sensor scan 0 to 180 degree. Okay, the radar show the coordinate of the object. Where is the object located? Okay. For the coordinate, we can use just put the slash update, and then we show the every single second that received to the radar is located like this. 300 meter, 300 meter, 300 meter, 300 meter, 300 meter, 300 meter, And then here we have the object 300 meter 72 degrees. Like you can see here, we put the object in front there, so it scan 300 meter 72 degrees. Okay, right now we want to demonstrate how the Airborne F4D detector system function. Okay, like you can see here, inside the radar, we like you can see, we have on the 70 meter to 60 meter we have the object. So like you can see, we have object. Okay, we start to move the Cessna to there, so it can scan the object in front of the Cessna. Okay, like you can see here, the F4D detector, we scan the object that block in front of the Cessna, then we send to the radar, and then we receive the information. Like you can see here, we have on the 150 meter we have something block. Okay, that's how the F4D detector function. You get some information from the sensor, scan object, and then send to the Wi-Fi, and Wi-Fi send to the radar, so it show the how located the object, where is the object is located. Okay, thank you.